Today we are looking at the law of cosines. The essential question is, how do I apply the law of cosines? Your learning intention: I'm learning how to use the law of cosines to find missing measures and to determine whether to use the law of cosines or the law of sines. So solve the two triangles. That means you're finding all the side lengths and all the angles. Pause the video and solve them. Well, I hope you tried. If you're looking at the first one, if this angle is 30, what does this one over here have to be? If you said 60, you would be correct. "30 plus 60 gives me 90. Now, this has now become a 30, 60, 90 degree triangle. 18 is my hypotenuse. 18 is, so if we're looking at it and thinking about the position, my smaller, this is x. This one becomes x square root of 3, and this hypotenuse is 2x. Okay, so if 2x equals 18, then x will equal 9. This becomes 9 square root of 3. And we have solved it without really doing much math, just remembering what we need to know. Okay, for the next one, we've got two of our three sides. Whose theorem do we use to find that third side? The Pythagorean theorem is correct. This is my hypotenuse. I'm looking for a leg. So x will be equal to the square root of 15 squared minus 12 squared. If you've got the hypotenuse and are looking for a leg, you have to subtract. We end up with 9. X is equal to 9. Okay, I'm going to give them some names here. I'm going to call this one A and this one B. To find the measure of angle A, sine, cosine, or tangent. Doesn't really matter. So let's look at it logically. Opposite over hypotenuse is sine. So the sine of A is equal to 12 over 15. Now, if I was looking for the fraction, I would have to simplify. But since I'm looking for the angle measure, I simply take sine inverse of 12 divided by 15. So I'm going to do second sine 12 divided by 15, close it off, and I get 53.1. So it is about 53.1 degrees. Now, for angle B, I could do the same process again, or it might be quicker and easier just to say 90 degrees minus 53.1 degrees equals 36.9 degrees. And this is the measure of angle B. So, you could have used sine, cosine, or tangent again for angle B. You can take 90 degrees minus. You can take 180 degrees minus the sum of 90 plus 53.1. Whichever way you see it. You're always using your strengths to find the answer. This brings us into the law of cosines. Now, if you're looking, you start looking at it and it looks like a hot mess. But let's look at the relationships. Okay, C is equal to, or C squared is equal to, and over here you've got cosine C. You're squaring the two sides and then you're subtracting 2 times AB times cosine of C. So if we're looking, and if we remember how it's set up, this would be side C. This would be side B, and this would be side A. So we're going to apply that first formula. C squared is equal to 29 squared plus 13 squared minus 2 times 29 times 13 times cosine 41. What is the opposite of squaring? Square rooting. So C will be equal to, and I'm going to do this all in one step. The square root of 29 squared plus 13 squared minus 2 times 29 times 13 times cosine of 41. Second, square root 29 squared plus 13 squared minus 2 times 29 times 13 times cosine of 41. Now I've got it all in. I hit enter and I end up with 20.998. That is just about 21. Using law of sines or law of cosines, you're going to end up having that approximation. What about the angle measures? Do we need to use the law of cosines again? No. We can actually use the law of sines. When you use the law of cosines, normally you'll only use it one time, and then you switch to the law of sines. So let's set up and find the measure of angle A. So this is our matching pair, 41 and 21. So the sine of 41 degrees over 21 will equal the sine of A over 29. Do that cross multiplication. 29 times the sine of 41 degrees. Close it off. Divided by 21. Remember, we're going to get that decimal. Go out to the here where you've got 4 decimals. It'll be 0.9060. So I'll use my sine inverse. 0.9060, and that is approximately 64.95. That's approximately 65 degrees. Okay, when you find two of your angles, the quickest way, rather than even using law of sines, is your triangle sum theorem. So I will set it up as 180 degrees minus 41 degrees plus 65 degrees is equal to 74 degrees. And so we know that B is 74 degrees. Any questions? If you're still struggling, go back it up and try it again. Listen to it again. So, as we go on, can you identify the pieces? Which side is A, which side is B, which side is C? This is A, this is B, this is C. Now, the relationship is always the same. A squared equals, now you're going to use your other two sides, B squared plus C squared minus 2 times B times C times cosine of A. It's always, this side squared is equal to this squared plus this squared and the rest of that equation. So, we know what A, B, and B are, or B and C are. So can you set that up? We're looking for A squared. Okay, to set it up, A squared is equal to B squared, that's 21 squared, plus C squared, that's 30 squared, minus 2 times 21 times 30 times cosine of 123. Remember, the opposite of squaring is square rooting. So I'm going to square root the whole thing so I do not have as much chance of making a mistake with the math. (21 squared plus 30 squared minus 2 times 21 times 30 times cosine of 123. 40.02, so that is approximately 40. Okay, now it should be 45, sorry. Approximately 45. Now we can use the law of sines to find the angle measures. Once you use the law of cosines one time, you use the law of sines. So my matching pair is angle A and side A, so the sine of 123 degrees over 41 or 45 is equal to the sine of B over 21. It's time to find that fraction, or that decimal actually. Okay. 21 times the sine of 123, close it off, divided by 45 is approximately 0.3914. Sine inverse 0.3914 is about 23 degrees. Okay, so this time I'm going to use the triangle sum theorem to find that last side. 180 degrees. Minus 123 degrees plus 23 degrees is 34 degrees. We've got all of the angle measures. Okay, for the next one, if you notice, there are no angle measures. When you have to find that first angle, it is quite involved with the math. So, here we go. Which angle do you want to find? It doesn't matter. If you want to find angle A, then we start with a 10 squared. So 10 squared is equal to it will be 11 squared plus 17 squared minus 2 times 11 times 17 times cosine of A. We're going to chunk. Okay, I'm going to start by chunking these two together. I have to subtract this number to get this expression by itself. So from both sides, I'm going to subtract 11 squared plus 17 squared, and I do that in parentheses. If you notice, I am expecting to get a negative number. So 10 squared minus parentheses 11 squared plus 17 squared, and I've got negative 310. Is equal to negative 2 times 11 times 17 cosine of A. Once again, I'm going to chunk it. I've got to get the cosine of A by itself. This is multiplication. The opposite of multiplication is division. I have to use parentheses. Okay, so I expect to get a positive decimal. Divide by parentheses negative 2 times 11 times 17. There's my decimal. 0.8288 would be 0.8290. Use your cosine inverse. And you end up with 34 degrees. Okay, so I found that first angle, which is angle A. Now I will use the law of sines, because this is really involved. Could I use the law of cosines again? Yeah, I could. But it is easier to switch to the law of sines at this point. I've got 34, the angle 34, and the side 10, which match up. So the sine of 34 over 10 is equal to, you want to find it, B or C first. We'll find B, so it'll be the sine of B over 17. Do your cross multiplication, 17 times the sine of 34 degrees divided by 10. Go out to the fourth decimal spot. Zero 0.9506. So I'm going to use that sine inverse. Second sine, 0.9506, close it off. 71.9, so that's approximately 71.9. Now, triangle sum theorem is how we will finish strong. 180 degrees minus 34 degrees plus 71.9 degrees is equal to 74.1 degrees. So, law of cosines, if you're looking for a side, it's fairly easy. You just plug and chug. You put all the numbers in, square root the whole thing at one time, and you're done. If you're looking for an angle measure, there are several steps you have to do. You're going to subtract this number from both sides. Once you get that, then you're going to divide by that number. Could we have gone ahead and done a lot of simplification? Yes. But the more you simplify, the more chance you have to make a mistake. So if we can chunk as much as we can, then we'll have less chance of making a mistake. How do you know you're successful? When you can use that law of cosines to find missing measures, and when you know whether to use the law of sines or the law of cosines to solve. Law of cosines.